This section, 12.3, is our second section looking at surface area. In this one, we're looking at pyramids and cones. If we start off with a pyramid, it's a polyhedron which the base is a polygon, and the lateral faces are triangles with a common vertex. So now they go up to the point here from the top. So we have a base, and then each vertex at the base connects to that vertex at the top, and that's different than a prism. The height of the pyramid is going to be that perpendicular distance between the base and the vertex. If we wanted to measure how tall the pyramid would be, that would be the actual height. A regular pyramid has a regular polygon for a base, and the vertex is centered, and that's typical to what we see. But the other thing we need to be aware of is the slant height, and that's the height of the lateral face of the regular pyramid. And here we have the height, like I said, is how tall the pyramid is. The slant height is this height on this triangle on the outside. So whereas height on the inside, slant height would be what you would slide down the outside of the pyramid. Now, we are dealing with surface area, so we want the height that's on the outside, on the actual surface, whereas this height is on the inside, and when we get to volume, you could imagine that that's the one we're going to use then. Height will be on the inside, slant height is on the outside, it's on the face, so we're going to use that for what we're doing. Now, what if they give us the height when we need the slant height? And here's a good example of that. If they do that, we're going to form a right triangle where our slant height is here, and we just denote that usually with an L, and we can solve with a right triangle because this 21 is the height, the 20 is half of the 40, so that gives us a right triangle to use, where we can now solve using Pythagorean theorem for our slant height, which would be L squared equals 21 squared plus 20 squared, which gives us 441 plus 400, which becomes 841, and then the square root of that turns out to be 29. So 29 would be our slant height. And that's going to be something very important we have to look for as we go through these. But to find surface area of a pyramid, our formula is a little different than with the prism. Now, with the prism, we had two bases. Today, as we look at surface area for the pyramid, we're only going to have one base. So, we need to area the base. The other thing we need to do is find the perimeter of the base times the slant height, and we need 1/2 of that. Now, if we look at why that's the case, I have my base here, and I have 4 triangles that actually go up and meet to form the pyramid. Each of those triangles has a slant height. That's the actual height of the triangle. And if I draw all 4 of those triangles together in a row, where each of these is L, I have the slant height for all of them, combined, their base value, that bottom value, is the perimeter. So, to find the area of all of these triangles, well, I'm going to use the way I would find the area of one triangle. The area of one triangle would be 1/2 the base times the slant height, and I would have 4 of them. By switching out the 1/2 with the 4, I get 1/2 times 4b times L, and we can again switch out 1/2 and make it perimeter times L. So this tells us how we get those actual areas of the triangles. If we go back to surface area of a prism, you could have found all the areas of the separate parts. We could theoretically find all the areas of the separate parts here. But it's that connection with perimeter. Using that perimeter together, we can find the areas of all of the faces, all those triangles, by doing 1/2 the perimeter times the slant height. And again, make sure your slant height is the height of, or the height of the triangles, or that distance on the outside. We want L, not H. If we had H, we would use Pythagorean theorem to solve. So, here's a good example of it. We have that height on the inside, which is 12. We want our slant height. To find it, we have a right triangle with 12, 5, and this is L. We can solve L squared equals 12 squared plus 5 squared. L squared equals 144 plus 25. L squared equals 169, so the slant height is 13. Now, to solve for surface area. Surface area is the base area plus 1/2 the perimeter times slant height. Now, let's draw our base area off to the side, or our base to the side. We know it's 10 by 10, so the base area would be 10 times 10, or 100. Perimeter would be 10 plus 10 plus 10 plus 10, or 40. And then again, we found our slant height as 13. We go to solve. It's 100 plus 1/2, 40 times 13. We get 100 plus 20 times 13. 100 plus 260 gives us 360 inches squared. Okay, we go to our next problem. Now we look at it, we're given our slant height to start. So we can kind of skip this step we did up here, but we're still going to draw our base to the side. It's 6 by 7. Our base area, 6 times 7 is 42. Our perimeter, 7 plus 6 plus 7 plus 6 is 26. We look to solve now. It's base area plus 1/2 the perimeter times slant height. That's 42 plus 1/2, 26 times 10. 42 plus 13 times 10. 42 plus 130 gives us 172 inches squared. Okay, let's go a little bit further now, and now look if we had a regular hexagon as our base to find our area. So, this is our formula we're going to use. We have a slant height, 14, so we know that already. We need the base area and the perimeter of the base. So we're going to use this hexagon to help us find it. Now, the perimeter of the hexagon is 10 times 6, because it's 10, 10, 10, 10, 10. So 10 times 6, or number of sides times side length, gives us that it's 60 feet. So that equals P. We have L. Now we just need base area. So that base area, or the area of a hexagon, is 1/2 the apothem times the number of sides times side length. Hopefully you remember that. Now the apothem is that height, that distance from the side, that perpendicular distance. It's the height of this triangle we would cut out. So that's 5√3 times the number of sides times side length, which we have 6 sides, times 10. This is the same as this, it should be. So I have 1/2 5√3 times 60. I could take half of 60 and get 30, and I get 150√3 feet squared. And that's the area of my hexagon. That is my base area. That's the next part I need. So I have all three values. I go up and plug them in. I get 150√3 plus 1/2 60 times 14. That gives me 150√3 plus 30 times 14. This ultimately becomes 420. Now that is in simplified radical form. We could leave it like that. If they wanted it as a decimal, you could plug it in and it comes out to be 679.8 feet squared. So, simplified radical form, first decimal place. Two answers, each would be the same thing. Okay, now let's look at a cone. So a cone is going to have the same idea as a pyramid, but it's going to have a circular base. And like it says here, it has a circle for a base and a vertex. The radius of the base is the radius of the cone, so we're going to use that radius. The height is the perpendicular distance from the vertex to the base, same as a pyramid. It's that that height, how tall it is, and we have slant height still. Now the lateral surface of the cone contains all the segments that connect the vertex with the points on the base edge. And what that's saying is if we just kept drawing lines from the vertex down to the circle, we would eventually have it going all the way around, and that represents the space that's the lateral surface. If you've had an ice cream cone, that ice cream cone, which is in a cone shape, is the lateral surface because that base isn't there. It's where you put the ice cream. So just that portion of the ice cream cone is the lateral surface. There would be a hole here. That's part of the base. Lateral surface would be the rest of it. So let's look at our surface area. Now, keeping the idea of a pyramid, we can kind of transfer it over to look at a cone. For a pyramid, we said correct some things here. We said it was area of the base plus 1/2 the perimeter of the base times slant height. So now we're going to keep that area of the base the same because it's pi r squared. And now we're going to have the radius of the base, or the perimeter of the base, be instead 2 pi r. But instead of getting to that 1/2, it just cancels out. So we ultimately have just pi rl to get down to. So, kind of lost here. Let's try that again. If I was looking at a pyramid, surface area of a pyramid, I would say it's the base area plus 1/2 the perimeter times slant height. Now, we've taken that pyramid idea, we're going to switch it to a cone. In a cone, we know what the base area will always be. It's pi r squared. The perimeter for a cone isn't, we don't call it perimeter, we call it circumference. So 1/2 2 pi r. We simplify the 1/2 and the 2, and that gives us pi r squared plus pi r l is the surface area for a cone. Now we clean it up a little bit. Alright, so this is our radius. That's r. Slant height is that height on the outside, and if they still give us the height here, we would use Pythagorean theorem to get to the outside. But again, this is all we need. We know the radius, we know the slant height, we can plug it in and solve. So, we'll look at a few examples of this. Now, in our formula, this portion is the lateral area. So our first example actually looks for the lateral area. So we're going to solve for the 1/2 perimeter times L, which isn't even necessarily perimeter. We should probably simplify that one. Pi r squared plus pi r L. That's the lateral area. So to find that, it's going to be pi r times slant height, but if we look over, we don't know slant height yet. We have to actually find that one, so again, we have to use Pythagorean theorem to find slant height. So L squared equals 20 squared plus 15 squared. L squared equals 400 plus 225. L squared equals 625, so our slant height is 25. So now we have that. Our radius is 15. So we can find the lateral area, which is pi times 15 times 25, which comes out to be 375 pi yards squared. So then when it comes to finding surface area, which is pi r squared plus pi rl, we already know what this is. That's 375 pi. So we just have to solve for the first part, which is pi times 15 squared, which gives us 225 pi plus 375 pi, which is a total of 600 pi yards squared. Okay, the last one we had, we needed to find the slant height. This one, they already give it to us. So make sure you're clear. If we're looking for surface area, we look at the outside value. So I get pi r squared plus pi rl. 15 is r, or 15 is slant height. Radius is 4. Pi times 4 squared is pi times 4 times plus pi times 4 times. I'm having some problems here. Try again. We're looking for surface area of a cone on this problem. Pi r squared plus pi rl. 15 is our slant height. 4 is the radius. I plug in pi times 4 squared plus pi times 4 times 15. I get 16 pi plus 60 pi. Combine those and it's 76 pi inches squared for my surface area. Last one here. I need to solve with Pythagorean theorem to find my slant height. In order to do that, I have 5, 8, and L for values. L squared equals 5 squared plus 8 squared. L squared equals 25 plus 64. I get 89. Slant height is the square root of 89. So then when I go to find surface area, pi r squared plus pi rl. Pi times 5 squared plus pi times 5 times the square root of 89. I get 25 pi plus 5 root 89 pi, and this is simplified in terms of pi and simplified radical terms. It's not a very nice answer. It would work. It's accurate. If we then went to plug it in our calculator and round it off for a decimal, it would not be as accurate. It would be approximation. So that would work, but to give us an idea, that is 162.1 feet squared once we plug it in.